All right, in this video, I'm going to just go through some of the problems off the Chapter 6 review. Primarily doing this, several of you were absent, and I want to be sure you understand how to simplify. At the end of the problem, there's usually these complex fractions. I want to make sure you're okay with those. Okay, so I'm just going to select a few problems off the review to do as an example. If you were in class, you've already seen this. All right, so when you're doing a problem like tangent of 285 degrees, you're not supposed to just plug it into a calculator. What you do is you try to think about angles on the unit circle that you could use that would wind up being 285 degrees. And a lot of times there's more than one option, okay? So for instance, I could do 315 minus 30, and that would be 285. And there is a sum or difference formula involving that. Or another option might be 225 plus 60. Okay, that would add up to be 285, and 225 and 60 are both on the unit circle. So, you just find one that works. Okay, so I'm going to use the 225 plus 60. Then you go to the sum or difference formulas and you look at what it says. So this is like your alpha, this is like your beta. Okay, so it says it should be tan alpha plus tan beta over 1 minus the product of those two things. That's the formula. So in place of alpha, I'm putting 225 degrees. In place of beta, I'm putting 60 degrees. And then I do 1 minus the product of those two. Okay. All right, so now this is going to wind up being a complex. Well, no, this one doesn't. This has a different issue. So this one, the tangent 225, you can look on the unit circle. That's over there in the third quadrant. The coordinates of the ordered pair are the same. So if you did sine over cosine, you'd get 1. All right, then the tangent of 60, you'd have to be thinking about when you're on the unit circle over there. Let me find my unit circle so I can show you what I'm talking about. So when you're over at 60 and you're thinking about just the tangent of 60, that's the square root of 3 over 2 divided by 1/2. Okay, and when you do that, this is a complex fraction, so you can multiply by 2 and you'll get square root of 3 over 1, which is just the square root of 3. In the denominator, we have 1 minus those two things, 1 times the square root of 3. All right, so what you have right here needs a little bit of work because you have 1 plus square root of 3 on top and 1 minus the square root of 3 on the bottom. So you have a radical in the denominator. So there's just a little bit of algebra skills I wanted to remind you of on this Chapter 6 material. To me, the trig is not the issue. It's after you've plugged into the formula, being able to get it simplified correctly. So remember when you have like two terms and you have a radical in the denominator, you have to rationalize the denominator. Okay, so what we're going to wind up with here is 1 on the bottom, 1 plus the square root of 3 minus the square root of 3 minus the square root of 9. And on top, we'll have 1 plus the square root of 3 plus another square root of 3 plus the square root of 9. And some of you may know that the square root of 3 times the square root of 3 is just 3. But if not, this usually helps you see it. So see on top, we have 1 plus 2 square root of 3, and then square root of 9 is just 3. In the bottom, we have 1 minus 3. So we wind up with 4 plus 2 square root of 3, all divided by a negative 2. And then if we divide negative 2 into both terms, we wind up with negative 2 minus the square root of 3. And that would be your final answer. So my concern is that you'll do okay on the trig part, getting to like right here. And I just wanted to be sure you could finish it. So I'm doing several problems on the sheet to try to help you with that. All right, let's look at, I looked at number 13 in class, and I'll do that one, but let's do another one of those because these are kind of the most important ones. Let me see. Let me look at, I'm trying to decide between 11 and 12. Let me go ahead and look at question number 12. So I'm going to do 12 and 13. So on question number 12, this is an important type of problem. You're given that the cosine of some angle is -4/5, and you know that the angle is in quadrant 3. Okay. Then you're given that the sine of a different angle, beta, is square root of 21/5, and that beta is in quadrant 2. Okay. And then your job is to find, ultimately, I'm going to leave a little room because I want to draw some pictures. Ultimately, you want to find cosine of alpha plus beta. All right. And you are not really ever going to find out what alpha is or what beta is. Okay. You're just going to use the formula for the sum, cosine of the sum of two angles. And so you're just going to use this formula that says cosine would be cosine alpha, cosine beta. Okay. And then if it starts out plus, it's going to be minus for that formula. Make sure you're copying and writing the correct formula. So I could find cosine of alpha plus beta if I knew these 4 things. And I know 2 of them. So I know this is -4/5. And I know the sine of beta is square root of 21/5. But what I got to do is find cosine of beta and sine of alpha. Okay. So what you're going to do is draw a picture. Quadrant 3 is where your angle is located. Make that triangle. Draw the perpendicular to the x-axis like we usually do. And then put this on the triangle in the right spot. So if its cosine is -4/5, you know the 5 is here, you know the 4 is here. And if you'll put the negative on it, even though that is just a length, if you'll put that it's -4, the direction, that'll help you make sure that you'll have the correct positive or negative on the other values, okay? And then you've got a missing spot. Now, when it's something like this, you know that a 3, 4, 5 triangle is what that's going to turn out to be. You've seen that a lot. Then just go ahead and put that. But notice that 3 is down, so make sure you get the negative on it, okay? You could just use the Pythagorean theorem if you didn't know that. All right. And so once I have that picture, then I can go in and get the other things I need. So I needed the sine. So now I know that the sine of alpha, based on that, would be -3/5. Do you see how if you didn't have the negative on the 3, then you might mess up? So if you don't put your signs like this here, then you have to think about, I'm in quadrant 3, so the sign would be negative, okay? So just double check that you have the correct sign, SIGN here, okay? By looking at the quadrant the angle is in, or by making sure you put the positive or negative on it when necessary, okay? Now for beta, it's in quadrant 2, so it's up here. 5 and sine is opposite over hypotenuse, so I'm going to do that. It would be a positive on both of those. I'm looking for that missing piece, and that one's not as obvious to me, so I'm going to have to set it up. So I know that square root of 21 squared plus something squared is going to have to, I'll put a little x in there. It's going to have to equal 5 squared. And square root of 21 squared is going to be 21. 5 squared is 25. All right, so x squared is 4. So x is either positive or -4. So the length is 4, but it's to the left. So this point would be to the left 4 and up 5. So I'm going to put a negative on it. All right, and then in the formula, I already have the sine. I just need the cosine of beta. Now that I know that missing side, I know cosine would be -4/5. Okay, so now I'm going to go and put all that information into the formula. So cosine beta is -4/5 also. Okay, sine alpha is -3/5. And the formula has a minus there. Be real careful about all these formulas, okay? I feel like I messed something up because that's odd that would be a 4. So let me double check and see if I messed something up somewhere. So let's see. So that's 21 x squared, 25 x squared equal. Oh. This is plus or minus 2, isn't it? Okay. So if you were copying me, fix this right here. So this is going to be a -2, and so is that. Okay. I thought it was weird that they both had the same cosine, but were different angles. All right. So anyway, now we're to the point where we've got to work on the, getting this correct. So feel free to use your fraction keys, but your answer needs to be in simplest radical form. Okay, so and multiplying fractions is easy enough. You just multiply straight across. Okay. This is a negative times a positive, so it will be negative 3 square root of 21 over 25. Okay, and then minus a negative becomes plus. So this one's not so bad because you already had common denominators. So it's 8 plus 3 square root of 21 over 25. Okay, and that is your final answer. All right, so let's try one more that has more with the issues at the end when you're simplifying. But this is important. Know how to do this. Okay, being able to think about it, draw the picture. This all goes back to really that chapter 1 when you think about it. Okay. All right. Now let's look at 13. So there we have the tangent of alpha given to us. This time they tell us the quadrant in a different way. So this is just supposed to tell you what quadrant you're in. So you kind of think about it. Here's pi. Here's 3 pi over 2. So you're in the quadrant 3. Okay, it's just a different way of giving you that. Then cosine beta equals negative 3/5, and they tell me that beta is between pi over 2 and pi. Okay, and so there's pi over 2, so it's in the second quadrant, so it's in quadrant 2. So that means when I draw my pictures, tangent is supposed to be in quadrant 3. That's not what I meant. Alpha is supposed to be in quadrant 3, and beta is supposed to be in quadrant 2. Okay. All right, now let me think about what I'm trying to do. I think I could save more time if I would think about that ahead of time. Sometimes I just go on and find everything I can about both angles, and then it's not really necessary. So on this problem, I'm trying to do tangent of alpha plus beta. So the formula says I do tangent of alpha plus tangent of beta, and then 1 minus the product of those two things. Okay. All right, so really I just need tangents. I don't need sines and cosines. So I already have the tangent I need here, so I guess, don't need to do that picture. Over here I do. So cosine. Cosine is adjacent over hypotenuse. This is a 3, 4, 5 triangle, so I know that's 4, and it'll be positive 4. And so when I do tangent of beta, it's opposite over adjacent. So it'll be negative 4/3. And double check the sign another way. I'm in quadrant 2, so I do know tangent will be negative. So that looks good. Okay, now I'm going to plug into the formula. So tangent of alpha I was given. I just found beta, tangent of beta. And so I'm just plugging into the formula. You see that? All right, now when I do that, I have some fraction work to do here. This turns out to be 20 over 21, really minus 4/3. And down here, I'll go ahead and do the multiplying. That'll be minus, that's 20 times the negative 4 would be negative 80 over 63. And minus a negative 80 is plus 80 over 63. Okay. Now, at this point, I'm okay with you using a calculator to try to simplify the fractions if you want to use your fraction keys, but there really is a nice, fun way to do this. If you look at all the little denominators and you think about the least common denominator for all of those, it would be 63. So if you multiply the top and the bottom by 63, that 63 would have to get distributed, wouldn't it? So you're going to need a 63 next to everything, because you got to multiply all the way through. But let me show that better since this is the first one I'm doing, and then I'll take shortcuts maybe later. Okay, so what I'm doing is saying it's okay to do this, right? And that's because 63 over 63 really is 1, so I'm not changing the problem. I'm just trying to clean it up a little bit. Then I'm going to distribute that 63 to both terms, okay? And that's where I was at. So I was going to write the 63 next to each of them, top and bottom. And so I wind up taking 60 times the 20 over 21 minus the 63 times the 4/3, and then 63 times 1 plus 63 times 80 over 63. When you get the hang of this, you could probably go from here to this idea. I think it does help, though, to write the 63 next to everything so you really see what nice thing happens. Divide there, you get 3. Divide here, you get 21. Here, you get just 80. So you wind up with 60 minus 4 times 21 would be 84. Okay, all over 63 plus 80. So that's negative 24 over 143. And that would be your final answer. Okay, so that last part can be daunting. It's like not the trig part. The trig part's not so bad, but you got to be able to finish it up. But you are going to be showing your work so that I can give you partial credit when it comes time, on tests and things. All right, so what I did is just try to look through some that, had some algebra skills that you might be less familiar with that I could help you with. I'm doing a couple more than I did in class, but basically I'm doing the ones I had in class. Okay. Let's look at this one, 17 on the review. Okay. It had the sine of theta is 12/13. Okay. We know theta is in quadrant 1. Okay. And we're being asked to do, actually, that's not as hard as 18. Let me change it. I'll do 18. I want to do them both. That one had sine of theta being 8 over 17, and theta was in quadrant 2. And our job was to find tangent of 2 theta, not tangent squared theta. Make sure you see the difference between that. It's just tangent of twice the angle. Okay. Okay, so you got to be careful on this one sometimes. So what you're going to wind up doing here is using the formula. So go find the formula. It says tangent of 2 theta, and on that, it's going to equal 2 times tangent theta over 1 minus tangent squared theta, okay? So the formula, if we plug it in correctly, it's going to give us the answer. So we just need a bunch of tangents, but we're being given sines. So we're going to come in here, draw the angle in the second quadrant. Sine is opposite over hypotenuse. I need the adjacent side to do tangent. So I'm going to set that up. 8 squared plus the missing side squared has to equal 17 squared. That's 64. That's 289. So x squared would be 225. So x would be 15, positive or negative. And on here, it's in the second quadrant. So I want that to be, to get to that point, I'd have to go to the left 15. So I want to put the negative on the 15 so I have my sign correct. All right, so then I just need tangent of theta. So now tangent of theta should equal opposite over adjacent. So it's negative 8/15. If you didn't put the sign on it on your triangle, then you should think you're in quadrant 2, so you know tangent has to be negative. Either way, you got to get that tangent to be negative or you're going to mess up. So now you go to the formula, and in place of tangent theta, you put negative 8/15. And then you do 1 minus, and the negative 8/15 is tangent theta, and that has to get squared. Okay. So that's like 2 over 1. You're just multiplying straight across. That's going to be negative 16 over 15. And then down here we have 1 minus, and be careful. The negative 8/15 gets squared and becomes positive 64 over 225. And then the formula had a minus in it. So there's a lot of places where your mistake might be a sign error or something to that effect. So you need to be real careful. All right, now here, see how I have a complex fraction? Let's use that little idea I was teaching you. This is 15. this is 15, this is 225. I could use 225 and multiply the top and the bottom by 225, okay? If I did, that 225 would get distributed, wouldn't it? So I'd do the 1 times the 225 minus the 64 over 225 times the 225. It has to get distributed. And then I'd multiply the top by 225, okay? Normally, this is the first step I show because I know I'm going to multiply top and bottom by 225 and get everything distributed, okay? So why I did that is 15 goes into 225 15 times. Here, the 225 cancels out. So on top, I have negative 16. Negative 16 fifteenths times 15, and the negative 16 times the 15, let me double check that. Is negative 240. And on the bottom, I have 225 minus 64, so that's negative 240 over a positive 161. And if that could simplify, I would divide by a common factor, but nothing's common. So that's my final answer, okay? All right, let me stop on that. We're about to get started on half angles and then equations. And if the video gets long, I know you have trouble loading it. So let me